the topics that we're going to go through. It's going to, like I said, it's going to be about 20-30 minutes. Then we'll have some Q&A, and we'll just do that through typing in questions at the bottom on the chat. But like I said, every company is a little bit different, so some of these topics you may already be familiar with, some are not. For those that are not familiar with it, we'll talk briefly on it, and we can talk in a longer time offline if there's some questions or things you have on something. The goal is to provoke some thought on how to improve the use of your CAD data throughout the manufacturing process. So we'll get started here. Why would you want to leverage this data? First of all, why not? I mean, you spend a lot of time and energy on documentation. Use it. Who wants to re-enter data? And what's worse than you spend all this time and energy to create a good document in the CAD design, and then it's not, implemented the way you hope because the data is not consistent. So, and the brass tacks, it's a business, and so you want to become more profitable. So if you can do things quicker, more productively with less chance for errors, that's a good thing. But reality is, why wouldn't you use this? Why wouldn't you leverage CAD data? Well, there are some situations where you wouldn't. Maybe there's no budget. Anytime you have, you're going to do a project, you have to have a budget. Your time is money. The company relates that to some burden rate that is time. And so sometimes there's just not enough time or budget to do things. Otherwise, you may have a legacy system, whether it's an ERP system or what have you, that just is not compatible with doing some of the things that we're going to talk about, whether it's sharing bill of materials or different things like that. Our team in IT can help with a lot of that, but that's a different session. But also sometimes, politically it doesn't work out because, I was recently at an organization and it was flat out there. They don't have an opportunity to do some things in manufacturing just because the leadership doesn't see it that way. So we understand it's not as simple as what it always sometimes appears, but what I like to think of is you create a vision you want to do, what you think is the best way to do it, and then work towards it, little bits and pieces at a time. So the first thing we'll talk about is jigs and fixtures. That's a very straightforward, every company uses jigs and fixtures. The difference is how you create them. In some cases you make a prototype. That prototype is the master. Then you build the fixtures around that master. In a lot of cases, the fabrication is the leader in that whole process, not the engineering. So, which may work fine for your organization, but doesn't work well for other organizations. So what I like to say is one project I can think of right in particular is we were working on, you take the CAD model directly and then you just build it just like you were building in a sandbox or at the workshop, your normal fixture, but you do it digitally. And so what that allows you to do is, make sure that you have access to get into parts where you need to do assembly. So you can spin it around. Yeah, I'm going to put this bolt in. Am I going to have access to get that? So you can visually see what's going on there. And also what was a huge advantage was the collaborative nature of that. So rather than just having a manufacturing engineer who can see the world through his perspective, but you can also call in the welders. You can call in the shop floor guys, the leadership there. So you can sit down and say, hey, how would you like to do this? And inevitably, there's always improvements to the process. You get everybody bought in, get everybody's feedback up front. So when it's time to start making those parts, right up front, you got a good solid fixture. That's a huge, huge advantage. And also, there's different things that you never think of, in, the warp when you're welding or different things like that. The guys that are doing it every day recognize how much that's going to be and areas that you can, minimize that. And you wouldn't do that unless you pull them into the process and give them a good visual tool to work with. The other thing is, even just as simple as if you have an oven or different things like that, you're putting on coatings or whatever, you can use that CAD data and drop it right onto an assembly line or a conveyor and understand how to arrange parts and different things on there to maximize the space within it. That was just a recent situation with one of our customers too. They wanted to be able to get, 3-4 different assemblies in on this conveyor because it goes in and then backs back out after it's done cycling. And so they were able to figure out all that ahead of time rather than scratching it around on a piece of paper and trying to figure it out that way. So that was pretty nice. Also, so jigs and fixtures, there's just a number, and like I said, a lot of companies already use this, but it also allows you just the collaborative, predictive, visual setup that you can use. Doing jigs and fixtures with your CAD data is really quite cool. The next section is CAM integration. Again, a lot of people have probably used CAM. I've got a real short video on this too that is pretty neat. It just kind of gives you some simulation. For those who haven't been using it too much, you can get into toolpath simulation. You can go paperless if you're using CAM in this situation. We have a company we work with that they don't make any prints. Maybe just highlight a few sections on the part that are QC checks where you need to measure, but other than that, there is no drawings. And CAM is one of those situations you can do that. So let me play this video. It's on YouTube, so it'll be a little bit of a jump here, but I'll get it on the screen. Like I said, I'm not a technical wizard.
Whether you're a veteran CNC programmer or a designer or engineer, as Inventor users, you all have one thing in common. You want a professional CAM solution providing you with all the tools you need in a system designed to work the way you work. Inventor HSM is more than high-quality toolpaths and a great user interface built on the industry-leading 64-bit multi-core CAM engine, which includes powerful and dynamic toolpath simulation so users can see what they'll be machining long before they post their files. Inventor HSM includes 2D adaptive and contouring to make the short work of even the most complex projects. Need 3D machining? No problem. Inventor HSM offers both 3D adaptive and pocket roughing, not to mention the industry's most complete set of finishing strategies, producing the highest quality of parts in the shortest time possible. Power users will be happy to know that Inventor HSM supports rest machining, form tools, a customizable tool library, and even allows you to create an unlimited amount of machining templates. Bottom line, when it comes to milling, Inventor HSM has you covered. Speaking of posts, Inventor HSM includes a super fast post-processing system, including a full library of user-editable post-processors for the industry's most popular machines. No CAM system will be complete without a great CNC program editor. That's why Inventor HSM includes one, complete with file compare, math ops, MC functions, backplotter, and reliable serial communications, so you can transfer your posted CNC programs to your machining centers without the need to purchase additional software. So what are you waiting for? See what Inventor HSM has to offer today.
All right, so that was just hopefully that one came through a little bit better, but that was just a video that kind of demonstrates the advancements that we have that are available in CAM these days. You could take your, well, hold on, I got it's playing it again. 1 second, please. There you go. Yeah, the part that's interesting is when you start to get into being able to watch the tool path go, know that you're not going to hit any areas that you're holding down the part in different areas like that. You can really estimate how long is that part going to take to get cut. So you can even go back and forth with that a little bit and find out, yes, this is a part that's going to be cut and it's going to take this long, and we know that the burden rate for that particular machine is so many dollars per hour, so we know it's going to cost this much. And that's what we're just trying to roll up to. So another area in manufacturing that's a very popular one, and like I said, most of I don't know about most, but there's a great deal of companies that are using nesting software. And nesting software, sure, it packs as many different parts on a sheet as possible if you're using a laser or plasma or water jet or router or whatever. You can get the different examples. But what's neat is that the ease that it's being done. We work with SigmaNest quite a bit, and the capabilities are just tremendous. So it's not just I need to make this part, and then how many can I pack onto this sheet, but you can do it to help facilitate assembly. With I'm going to make 4 machines. I need all the parts for those 4 machines nested. So it's not just one part. Like this visual here shows how it's going to nest these different parts. Quite frankly, it's a very quick return on investment. Typically, increases the efficiency of the machine. It's just a really nice way to do things. And doing it in the past, people have done it manually. That's pretty tough. You're never gonna beat the time and efficiency you're gonna get out of the software that way. The next thing I'd like to touch on is process mapping. For manufacturing, this is a big deal. Everyone seems to, how can we do this quicker, faster, better? That's the mantra. What the picture we have up there is just a picture I snagged off the web that just talks a little bit about a process map. You walk from this table to that table, this table, excuse me, and all that stuff ekes up. When you start to break it down, and if you go by work, what are you going to build? What workstations are going to be used? What's the operational sequence? What's each step in each sequence? And what are the details of each step? You start to break down the areas that are value, or non-value add, which I know a lot of people in manufacturing, you hear those words a lot, but you're always trying to remove the non-value add. You get rid of that, as much of that as you can. That shortens up how long it takes to build a product. And inevitably, to remove excess movement, what you find a lot is you're making assembly cart kits. Here's a couple pictures of different assembly cart kits. And they can be used in a number of different ways. There's many companies that are using carts regionally. It's very, very popular. It's very effective. And how you can, the beauty of using the CAD data for doing that is you can put exactly how much you need on there straight away. So you don't have to worry about, I need 4 assemblies, all the parts for 4 assemblies. Well, maybe you can put 2 of those assemblies on each cart. So you fill up those 2 carts, you roll it right to the work cell. All the parts are right there. They're not searching and hunting. Everything's really close. Everything can be placed in, excuse me, in a spot that's ergonomically correct. So you're not worrying about, how is, this person's going to bend over here and try to grab these parts and they're going to hurt their back. You can have it all loaded up at an acceptable level. Very visual, so you can see, yep, I got enough parts for 2 more assemblies here, or whatever it happens to be. So that's a huge thing, and you can build those carts, real simple carts, and you can build them with all the larger parts and smaller parts all hung and stacked on there. So it really works out slick. And so when we go build the carts, it's really straightforward. And you can also have a picture there too, so everybody knows how to load them and unload them. And so that's a very popular, very beneficial use of CAD technology there, CAD data. Let's see, move to the next slide here. Engineering BOMs. There's a handful. A full accounting of all the parts and pieces of, obviously, the bill of material. And depending on your organization, you may or may not run a production or an MBOM, manufacturing BOM, and then you also may have an engineering BOM. This is kind of a tricky one because a lot of times when you start talking about BOMs, a lot of things were limited in the past as far as engineering BOMs. because of hardware restraints. A lot of companies didn't put in certain parts because they knew they had, all the nuts and bolts and washers that are really going to drag down the system and not be able to, you know, it's going to slow down the whole thing. Don't put them in there. We'll just grab them from a bin. Well, in some cases, that may be the right way to do it. However, if you really want to integrate, and a trend that we're seeing is companies kicking and screaming, trying to go to one BOM. So an engineering BOM and a manufacturing BOM, it's one. So what you get into is when CAD data, when you're done with your assembly, you can export a BOM. Usually that comes in the form of Excel or something. Then you can push that into your ERP system. And a lot of times that's where it stops, is right before the ERP system because of translation issues. How does it get into the system? Not all the parts and pieces are there. How do we add to it? Our IT team works a lot with that connection and connects different software so they can talk to each other, so you can actually do that. But it gets down to data control. And then also you have to think of it more holistically. If you're building a computer, if you're doing that and you know that the keyboard is going to be built together, well, in manufacturing, you know the keyboard is going to be built together. So how would you put it together? And it gets a little tricky, and there's limitations, obviously, but if you could design and build your CAD model the same way it would be built on the floor or similar, everything else is going to get easier. All your peripheral information, your technical publications, your BOM structure, it all starts to work better rather than having to change it around. I understand that some design parameters or how you design things sometimes doesn't necessarily facilitate that. However, if you want to think about it that way, if you could just do that, there's some other added benefits that you would see. Say in the assembly process, when you're doing work instructions, if your BOM or if your model is already made in sub-assembly and assemblies that are conducive to how you'd actually build it out on the floor, well, all of a sudden the assembly process just got, documentation process for assembly just got a lot easier because everything's in the right assembly. Then you can start to break it down again by workstation, operations, and then also do that for the the bill of material consumed, so you're actually building, you have work instructions for the whole way through. So, and then in addition for the work instructions, it's also beneficial for training. A lot of organizations these days, especially in this region, have a pretty good turnover in the manufacturing lines. And so having good work instructions helps for that too. And so holistically, if you look at building your models and design in the same manner that it was going to be built on the floor, like I said, you can do this without doing it that way and just taking what you get and restructuring it, so you can do things, work instructions and different things more effectively. Yeah, that's always an option. But if you can, as a company, embrace the idea of designing it that way, it really can it can help all the way down the path. Here's some examples of some work instructions. I mean, you can go straight forward with your CAD data and then just do a hidden line removed, and you can just do the old bubbles and everything else, and it clears out all the background information, so sometimes it's easier to see when you're out there. Yeah, this is what I'm supposed to be doing. This part goes to here and that part goes there. Pretty straightforward. I mean, you've got, you have this for every workstation, operational sequence, each, all the sequence actions, and then you can actually build up a database of the actions. So you have, here, I'll go to the next slide here and I'll tell you a little bit more. This is an example of this was using a video, but I wouldn't recommend video just because of the amount of changes you typically are going to have out on the line. You're not going to want to make a video for everything. However, I just took a screenshot here, and if you look around at different things on there, each step description over on your right is very detailed, and each one of those detailed steps has a time associated with it. So if you want to think about all the actions that are taken out on the manufacturing floor, whether it's walking 6 steps, walking 8 steps, taking something off the rack, putting in a screw, it's all a giant database of different actions. And if those actions are all put together and you break it down to that level of detail and then build it back up, it becomes a pretty powerful tool. And that's a big trend that's going on right now, is taking care and making sure you know exactly how long it's going to take to do things before it's ever built. That's tricky, and it takes a lot of investment. But where you see it happening a lot is when you're talking about very high value products going down the line, and there's just not, they can't afford to have 3 months or 4 months of unproductive, ramping up time, because it just costs too much money. And so what a lot of these companies are doing now is they're taking the time and breaking it all down ahead of time. And so they know down to the second how long it's supposed to take. And so they can do their line balancing, the line layout, all the jigs and fixtures, everything all ahead of time. And it's very detailed. This particular screenshot also has the tool. It captures the tool, how many tools are going to be used, the name of the tool, and so they can actually have all this information in a searchable database along with the step descriptions. So if there's a part that changes, well, they know they have a field that says, okay, this is going to burn on the consume of the BOM. It's going to use this part, and this part. Well, if any one of those parts change, they can just look it up in the database and say, oh, okay, this is going to affect this work instruction, and we'll have to update those. And that's where you really start to see advantages, because you can search things. And because the common thing is, yeah, we made these work instructions, they're pretty good, but 3 days later after we did this ECO, they're pretty much junk. And so you can't keep them up. The maintenance is just a nightmare. So if you break it into a database form and start to break it down to its smallest components, and then rebuild it back up, each action up into a process, and each process into a sequence, and each sequence into a into a package of sequences into the workstation, and each workstation, add up all the workstations, you can see how you can start to build back up all your times and be able to, take a really good, accurate look at it and see that, yeah, this step's going to take this long, this is going to take that long, so you can start to do some preliminary line balancing right out of the gate without too much work. If you really want to get into it, there's a very dedicated effort right now it's just amazing. I've kind of looked at it as the same kind of paradigm shift that's occurring between, it went from, when you went from 2D to 3D CAD, it was a big shift, like, oh my, that takes a lot longer, or this, I could do it quicker this way. And pretty soon in those days, you're like, no, actually this is the way to go. I can see so much more, I can do so much more with the solid model. There's no question we need to do solid modeling. Well, I see that same shift going on in the manufacturing world. If you have all the CAD data and you build it all digitally, you can do all the studies. The picture on the left, that is a process where it's checking ergonomics, and so it'll identify areas where an operator is in an unsafe position that may lead to injury. The weight's too far from their body, they're in an awkward position. All that, it'll identify all that, so you can change. Say if that was a battery they're putting in, they may just say, you know what, they're on their knees, that's not a good thing. And then they're bending over and it's putting a load on their lower back. So you may quickly identify, you know what, we need a fixture, a little jack that we can bring up that part and slide it in, and then that person or the assembler is never going to get in a position which compromises their safety and could result in a work loss injury. And so that type of stuff can all be done ahead of time. And the picture on the right shows, okay, this person has got to put this component in, and maybe it's one of those that are kind of deep inside, because everyone's got so much extra room in their assemblies these days, just in case that was satiric. But yeah, so you can see this is what the operator is actually going to see. They are going to be able to get in there. Their hand is going to be able to have room so they can plug in this component or that component. So that's where everything's headed. In some cases, for one-off projects, it probably isn't going to work. It's just not, it might not be conducive to that. But there may be areas of your organization or manufacturing line where this type of analysis could be very beneficial. And the difference from the numbers I've seen for different companies that have done these type of in-depth assessments ahead of time, it pays back. The dollars are there. Granted, you have to be at an organization where they track. They know how much per inch of weld costs. They know how much each station costs. Typically, how much their line. They've already broke down all the details. It's not gonna make sense. You're never gonna be able to sell the idea of doing something like this if the sequences and actions aren't captured and costed ahead of time, because you wouldn't be able to justify this type of investment. But it's something that's definitely coming. It's fantastic. It's fun. It used to be only in the world's top manufacturers had the investment and the dollars to do this because the software was so off the charts. But this software is getting better. It's becoming more mainstream, and it really, I see in the next 5 to 10 years, this is really going to become similar to the 2D to 3D CAD change. It's